Hello friends. In this video, we will review another version of a smart energy monitor from the Tuya Smart ecosystem, which operates via Zigbee. This device uses a contactless measurement method with a current monitor ring that clamps around the phase conductor leading to the load. This design enables it to measure relatively high currents without the risk of malfunction or even fire in the energy monitor itself. Thanks to this feature and the design of its case, it can be used in an electrical panel for monitoring both individual power lines and the main input. Details will follow in my video, but for now, as always, I kindly ask you to like this video so it can reach more people interested in smart home technology, and subscribe to my channel if you haven't done so yet. Device type: energy monitor with current transformer. Model: ATMS1603AZ. Interface: Zigbee 3.0. Measured current: 0.2 to 50 or 63 amps. Input voltage range: 100 to 240 volts. Mounting: 35 mm DN rail. Width: 18 mm, 1 unit. There are two versions of this energy monitor, identical in appearance and sharing the same model number. The only difference lies in the measurement range. The model on the left is rated for up to 50 amps, while the one on the right is rated for up to 63 amps. Testing will be conducted using the higher rated version, 63 amps, but everything shown applies equally to the lower rated version. As mentioned, the device is designed in the form factor of a circuit breaker for mounting on a DIN rail. The back features a special groove and latch that allow it to be mounted and secured on the rail. Depending on the model, the package includes different current transformers. The higher rated version, 100 amps, comes with a significantly larger transformer, while the lower rated version, 50 amps, has a smaller one. The housing can be opened, making it easy to snap it around the phase conductor of the load. Inside, there is an arrow indicating the direction of the current from the mains to the load. It is essential to connect it correctly. On one side of the device, there is a wiring diagram. Power is supplied from the top, while the current transformer connects at the bottom. The contact pair for the transformer includes a black wire connected to terminal 1 and a red wire to terminal 2. The contacts for connecting the power line, phase, and neutral are required for the energy monitor to operate and to measure voltage. Thin wires can be used here since the load is minimal. For testing, I assembled a small bench setup. The neutral line, blue wire, goes directly to the socket, where the load will be connected, into the N terminal of the energy monitor. The phase from the mains, red wire, goes to the circuit breaker. From the same terminal, directly, a thin brown wire runs to the L terminal of the energy monitor, ensuring it is constantly powered. The phase, red wire, then exits the circuit breaker and goes to the socket where the load will be connected. The current transformer is clamped around this wire, ensuring the arrow points from the breaker to the socket. On the front of the device, there is a reset button. To switch the device to pairing mode, hold it for about 5 seconds until the LED next to it starts blinking. Now, we can proceed to functionality testing, starting with the standard control system, Tuya Smart. To use this device, a Zigbee gateway is required. The device automatically enters pairing mode after its first power-up or removal from a previous gateway. It connected correctly and displays the appropriate image. This is how the device plugin looks. At the top are the energy consumption indicators, total and for the current day. Below that are power, network voltage, and current readings. As far as I can tell, all readings are accurate. The plugin also includes a consumption graph page that can be viewed by day, month, and year. In the settings page, there is a memory mode for state and backlighting. Both features are more relevant for controllable relays and sockets, whereas this device, as we recall, has no relay. I will explain the related nuances later. There was nothing notable on the general settings page. There is no mention of compatibility with third-party control systems, and the firmware version is up to date. For resetting device data, you can use the delete and clear data option and then reconnect it. Let's take a look at the device's capabilities for automation. Functionally, it is intended to be used as a trigger since no actions can be performed with it. There are many options here, likely more than are actually needed. For example, there is a relay status option, even though there is no relay, and a test bit status. I'm honestly unsure what this could be, but it ranges from 0 to 5. It also reacts to errors generated by devices with threshold values, though none are present here. What can potentially be used are the energy monitor values, such as power, current, and voltage. I say potentially because there is another nuance I will demonstrate later in the video. Out of curiosity, I looked at the actions section. Surprisingly, actions were present, 5 in total. These involve setting certain energy monitoring parameters, which I believe are not relevant to this device, and configuring relay behavior after power restoration, even though, again, this device has no relay. Although compatibility with third-party systems was not declared, we will still check, especially since after linking the cloud account, all supported devices are automatically added. However, this does not apply to the energy monitor. It did not appear here. Regarding Homekit, I am using a gateway that supports this protocol and is connected to Home Assistant via the integration of the same name. It will also be displayed similarly in the Apple Home app. The energy monitor appeared as a relay or socket, with only a state toggle switch available for control. Spoiler alert. I managed to figure out what it does, but it's unlikely anyone will find it useful. So technically, the device was added to Homekit, but functionally, it makes no sense. Now let's check the Home Assistant integration, which works via the cloud and is called Tuya. The device is still connected through the gateway. The device was added, but by default, it does not have any active objects. In reality, they do exist. They are just hidden. Unveiling the list shows 3 basic energy monitoring sensors: current, power, and voltage. Clicking each object sequentially opens a settings menu in the top right corner of the screen. Each object must be activated individually. After activation, it takes some time for the integration to refresh and for the objects to appear in the system. This is how the data transmitted from the Tuya gateway looks. Now, about the nuance I mentioned when discussing automations. Data updates only when the Tuya app is open. Currently, a load is connected to the test bench socket, but the power reading is 0. If you open the Tuya app on your phone and access the Energy Monitor plugin, the data updates immediately. Similar behavior has been observed with other Tuya devices with energy monitoring, raising doubts about the reliability of automations based on voltage, current, and power data. Now let's move on to testing with third-party Zigbee coordinators and systems. As usual, I'll start with Sonoff iHost, a local smart home control hub. The firmware version at the time of filming is 2.3.4. It features a built-in Zigbee coordinator based on the EFR32MG21 module, which allows devices from various manufacturers to connect directly. The energy monitor was identified as a socket adapter. This is how it is displayed in the device list. The letter R in the top right corner of its tile indicates that it functions as a router in the Zigbee network. The controls include turning the non-existent relay on and off, as well as displaying current and power. Standard features for such devices, schedulers, timers, and cycles, are also available. Here, energy monitoring works quickly, with updates taking 5 to 10 seconds. I finally figured out how the relay toggle, which doesn't actually exist, operates. When it is in the off state, the monitoring sensors, even under active load, start showing 0. The power sensor typically reacts faster than the current sensor. I assume this is due to the firmware originating from an energy monitoring socket. If the relay is off, there can be no load. In the Settings tab, there is an option to select the state after power recovery. Given the above, it makes sense to set it to Always On. The manufacturer and model identifiers strongly resemble a series of popular energy monitoring sockets, from which the firmware was likely adapted. Let's check whether energy monitoring data can be used in iHost automations. Unfortunately, in the current firmware version, only relay states are available. Thus, the device can only be used for visual monitoring. One more interesting point. iHost supports the Matter protocol and is connected through it as a bridge to Google Home. Unlike Tuya Smart, this method allows the device reviewed here to be transferred. However, this doesn't add much value, as energy monitoring data is not displayed. Only control of the non-existent relay is available. Returning to Home Assistant, this time we'll use our own coordinators instead of the Tuya gateway, starting with the ZHA integration and a SkyConnect firmware-based coordinator. The energy monitor was detected and connected, revealing many objects. Let's figure them out. There's a relay switch. We already know its effect. Energy monitoring sensors include current, power, energy, and voltage. Settings include backlight adjustment and child lock, which only confirms my theory about the firmware being borrowed from a socket. The lock prevents children from turning off the relay with a button. There's also firmware version checking and behavior settings for power restoration. Energy monitoring works quickly, as mentioned earlier, within 10 seconds. No complaints about its direct functionality. I tested the relay switch, same behavior. Despite an active load, disabling the relay turns off the energy monitoring sensors, leaving only voltage readings. This is similar to real sockets. Here, we can do the opposite of what was shown earlier with the Tuya integration. Click the relay line, ensure it's on, and go to Settings. Then, disable it. No switch means no chance of accidentally disabling energy monitoring. I noticed no effect from changing the options in the backlight settings menu. Setting the mode to Always On worked as expected. After toggling the energy monitor's power, it resumed operation correctly. Now let's check Zigbee 2 MQTT, with the latest version at the time of testing being 1.41.0. The coordinator used is a networked version based on CC2652P. The energy monitor was detected and connected, as expected, as a socket adapter. Incidentally, I have one of these. This is a fairly common model with energy monitoring. There are many variations from different manufacturers, and the device under review is recognized as one of them. On the Exposes page, we see familiar options, mostly associated with sockets. A new feature is the countdown slider, an analog of the timer option in Tuya Smart. Interestingly, I found a rare peculiarity with Zigbee 2 MQTT. To update data, you need to manually refresh the web interface page by pressing F5. Otherwise, for example, when connecting a load, it will display zeros. However, in Home Assistant, where the device is added via the MQTT integration, such issues don't exist. Updates work fine without any additional action. All control options seen on the Exposes page are available here. Some energy monitoring parameters are hidden by default. To make them appear in the system, the same steps I showed earlier apply. Enable each required object in the settings. The device behaves the same as in ZHA. If the imaginary relay is on, energy monitoring sensors update every 5 to 10 seconds. If off, they show zeros. Thus, it makes sense to disable all unnecessary objects and leave only energy monitoring. It's hard to call this device perfect, but knowing its nuances, it can be used effectively to monitor both individual power lines and the main input. For Tuya Smart users, I'd recommend looking at other models since this one has a data update issue. You need to launch the app. However, for ZHA or Zigbee 2 MQTT, it's a fully functional energy monitor suitable for installation in an electrical panel. That's all for now. I hope you found the video helpful and interesting. I'd appreciate your likes, as they help promote it on YouTube. If you don't want to miss new reviews and tutorials, subscribe to my channel. In the description, you'll find links to stores where you can purchase this device, my social media accounts, Telegram channels, and technical resources. Thank you for watching. Until next time, wishing you all peace.